100 years ago, mathematicians predicted one such new state of matter. And since then, researchers have been looking for a very specific quasi-particle within it, the Majorana particle.
Microsoft just did something that has the entire tech world whispering in the dark. Their secret quantum lab, the one they have poured billions into for decades, just went quiet.
And this year, we were able to observe it for the first time.
Everyone is obsessed with AI right now. But while you were looking at chatbots, Microsoft scientists were hunting for a ghost particle that could break reality as we know it. They are claiming a massive breakthrough with something called Majorana, but then they started shutting doors and moving offices. It is not that simple though, because what they found inside that lab changes everything about how we protect our data. And get this, the truth is way wilder than a simple business move. Silent labs reveal a terrifying truth. Your phone uses bits, which are like tiny light switches that are either on or off. But Microsoft was building qubits. These can be on, off, or both at the same time. Basically, it is like having a superpower for math. But then, something weird happened. Microsoft started closing some of these labs, like the one in Sydney. People started asking why. If you find the most important thing in history, why would you turn out the lights? One of the most overlooked aspects of this story is what they call the Majorana particle. It is a ghost particle that acts like its own mirror image. Microsoft says they finally caught it. In February of 2025, they showed off a chip called Majorana 1. It had 8 qubits on it. That does not sound like much, but they say it can scale to 1 million. And that's putting it lightly because a million of these would be more powerful than every regular computer on Earth combined. But here's the catch. Right after they announced this, the silence started. This is a key detail that most people are missing. There are still many rumors on the air, but what many can confirm is that Microsoft changed their plan. They started moving their best people away from public view. Some say they found something that worked too well. Others think they hit a wall that regular physics cannot explain. When a company as big as Microsoft stops talking, you know something big is happening behind the scenes. They spent 20 years trying to find a way to make these computers stable. Regular quantum computers are very sensitive. If you even look at them wrong, or if they get a tiny bit warm, they stop working. It is like trying to build a house of cards in a windstorm. But Microsoft's new lab discovery was different. They used something called Topological Qubits. These are supposed to be much tougher. Instead of storing info in one spot, they spread it out. It is like having a secret code that is split into pieces and hidden in different places. This makes it really hard for mistakes to happen. But then the lab in Sydney was adjusted. Tech experts were confused. Why stop now when you are so close? A lot of people are confused about the real reason. Some say it is just about money, but others believe the lab found something they did not expect. They were working with temperatures colder than deep space. We are talking about minus 459 degrees Fahrenheit. That is almost absolute zero. At those speeds and those temperatures, weird things start to happen to matter. Particles start to behave like waves. Everything we know about the world starts to melt away. This is where the mystery begins. The lab was looking for Majorana zero modes. These are not even real particles. They are quasi-particles. They only appear when you set things up perfectly. Microsoft claimed they had 95% confidence that they found them. But then, the doors closed. If they have the key to the future, why are they hiding it in the basement? But the hardware is not the only thing Microsoft is hiding from the public eye right now. Strange particles that shouldn't exist. See, nobody expected this to happen, but the science behind this lab is like something out of a comic book. Most people are not seeing the truth here. To understand what they found, you have to understand how crazy these Majorana particles are. But imagine a particle that is also its own opposite. It is like being left-handed and right-handed at the exact same time. This was first talked about by a guy named Majorana in 1937. He disappeared shortly after, which is a whole other mystery. For 80 years, nobody could find this thing. Then Microsoft decided to spend billions to build a lab just to hunt for it. Why? because these particles are the key to a computer that never makes mistakes. Hands down, this is the hardest thing in science to do. Most quantum computers from companies like Google or IBM use tiny loops of wire. They work, but they are very glitchy. Microsoft took a different path. They use tiny nanowires made of special materials. These wires are thinner than a human hair, maybe only a few hundred atoms wide, and they coated them in a superconductor. When they chilled these wires down to nearly 500 degrees below zero, they saw something. The ends of the wires started to glow with quantum energy. That was the Majorana mode. And get this, these particles do not just sit there. They remember where they have been. This is called braiding. If you move these particles around each other, they create a physical knot in space and time. That knot holds information. Because it is a knot, it is really hard to undo by accident. That is why Microsoft's lab was so special. They were not just building a computer, they were knitting reality. But here is the catch. The more they studied these knots, the weirder the data became. Some scientists in the lab started to report things that did not make sense. The math was showing that these particles might be connected to things outside our 3 dimensions. Basically, it looked like the computer was pulling answers from somewhere else. This is a key detail that might explain the sudden lab changes. If you are building a machine that touches other dimensions, you might want to keep that a secret too. Everyone's obsessed with how fast these computers are, but the crazy part is how they actually work. They do not just do one thing at a time. They explore every possible answer all at once. If you were in a maze, a regular computer would try every path one by one. A quantum computer would just grow like a fog and fill the whole maze instantly. Microsoft's lab found that their topological version was even faster than that. But they also found that it was incredibly hard to keep the lab running. The materials had to be perfect. One speck of dust could ruin everything. One tiny vibration from a passing truck could break the quantum spell. This is why they built these labs in secret locations, with huge concrete floors. They needed total silence. But the silence that came after the lab was adjusted is what has everyone worried. Many are not seeing the truth here, which is that the lab might have succeeded in a way that scared the bosses. The quest for a perfect particle might have led them to a door they cannot close. Retracted papers and broken promises. It is not that simple, though, because Microsoft has a history of being a bit too excited. Back in 2018, they put out a huge paper in a famous journal called Nature. They said they found the Majorana particle for sure. The whole world cheered. It looked like Microsoft had won the quantum race. But then, other scientists looked at the data. They found that the lab had picked and chose which numbers to show. It was a huge scandal. By 2021, they had to take the paper back. This was a massive blow. A lot of people were confused about how such a smart team could make such a big mistake. Some thought they were just rushing to beat Google. Others thought they were trying to keep their funding. But some people think the data was not wrong, it was just too strange to explain. After that, Microsoft went back to the drawing room. They spent 3 more years in total secrecy. They changed how they made the chips. They worked with Purdue University to get better metals. They developed something they called topoconductors. These are materials that only conduct electricity on the outside, not the inside. It is like a piece of bread where only the crust is made of metal. By February of 2025, they were ready to show the world Majorana 1. This was supposed to be their big comeback. They said this new chip proved the old experiments were not just luck. They claimed they had measured the topological gap, which is a fancy way of saying they proved the particle was stable. But even with this new proof, the skeptics were not happy. Physicists are divided. Some say the signals are still too noisy. They say Microsoft is just seeing what it wants to see. And get this. The crazy part is that while the public was arguing about the math, Microsoft was already moving on. They started winding down operations in places like Sydney and focusing everything on the cloud. This move to Azure Quantum is what most people don't realize is the real secret. They are not just building a computer you can touch. They are building a ghost computer in the sky. You will not have to own one. You will just rent time on theirs. This gives Microsoft total control over who uses it and what they use it for. It also means they can hide the hardware wherever they want. No more public labs with tours, just dark rooms with big cooling tanks. This is a key detail because it takes the science out of the light and puts it back into the shadows. Many think this is because the technology is now so powerful it could be dangerous. We are talking about the ability to crack every password on the internet in seconds. If Microsoft has that, they have the power to see everything. Every bank account, every government secret, and every private message. That is putting it lightly. It is the end of privacy as we know it. The biggest breakthrough in history might also be the most dangerous weapon ever made. Multiverse links and simulation theory. And get this, the crazy part is the wild theories that started popping up after the labs went quiet. When science gets this weird, people start looking for even weirder answers. Some people who worked near the labs whispered about physics anomalies. They claimed that when the quantum chips were running at full power, the clocks in the building would desynchronize. We are talking about a few milliseconds of difference that should not be there. This led to a theory that the Majorana particles were actually interacting with other versions of our world. See, some scientists believe in the multiverse. They think there are millions of other Earths right next to us. Usually, we cannot touch them. But quantum computers might be different. They might be using the computing power of those other worlds to solve our problems. This is a key detail that changes how we think about the universe. If Microsoft found evidence of the multiverse, that would be the biggest discovery ever. It would prove that we are not alone, but in a way nobody expected. Then there is the simulation theory. Some people think our whole world is just a computer program. If that is true, a quantum computer would be like a glitch in the code. It would be a machine inside the program that is faster than the program itself. People speculate that the lab closure happened because they hit a wall. Maybe the simulation did not like them poking around. There are even rumors that the discoveries involved consciousness. Some think that the way these particles behave depends on someone watching them. This is a real thing in quantum physics called the observer effect. But the rumors say Microsoft took it further. They think the lab found that the human mind and quantum particles are linked in a way we do not understand. Basically, we might be living in a world where our thoughts can actually change reality at the smallest level. This is why some think the government got involved. There are whispers about black projects and military defense. A computer that can predict the future or see through walls would be the ultimate prize. Some say the Majorana tech is being used to build unbreakable communication for the military. Others think it is being used to model global events before they happen. They could predict the stock market or even the next big storm with perfect accuracy. One of the most overlooked aspects is the Q-Day scenario. This is the day a quantum computer becomes strong enough to break all modern encryption. If that happens overnight, the whole world changes. Every secret is out. Every bank is open. It would be total chaos. Many believe Microsoft already hit that point, and that is why they went silent. They are preparing for a world where they hold all the keys, and that's putting it lightly. We might be looking at a future where one company knows everything about everyone. The secrets they found might be so big they have to stay hidden forever. Future of our digital world. The pursuit of quantum supremacy is often framed as a corporate milestone, but this perspective fails to grasp the true scale of the conflict. This is not a standard development cycle for a new consumer product. It is the definitive space race of the 21st century. While the public focuses on the fluctuating stock prices of Microsoft, Google, and IBM, a silent infrastructure war is being waged in specialized labs across the globe. The stakes are not merely market share, but the fundamental ability to decrypt any existing security protocol and simulate the material world at the atomic level. Google and IBM have taken the traditional route, utilizing superconducting transmon qubits. These are effectively tiny loops of wire where electricity flows without resistance. They are impressive, but fragile. They are susceptible to the slightest thermal or electromagnetic noise, leading to decoherence, where the quantum state collapses and the data is lost. Microsoft, however, decided to ignore the easier path. They chose to hunt for the Majorana Fermion, a particle hypothesized by Majorana in 1937, that acts as its own antiparticle. This is the foundation of the topological qubit. The logic behind the topological qubit is grounded in braid theory. Unlike traditional qubits, which store information in the state of a single particle, a topological qubit stores information by braiding paths of these Majorana particles. If a stray photon hits one part of the braid, the overall structure remains intact. It is a system built for stability in an inherently unstable environment. However, the Majorana fermion has proven notoriously difficult to isolate. For years, skeptics argued that Microsoft was chasing a mathematical ghost, a particle that existed in equations but could never be manifested in physical hardware. The recent closure of high-profile labs, such as the facility in Sydney, has been interpreted by many as a sign of failure or a tactical retreat driven by fiscal tightening. Yet, this ignores the nature of high-stakes research. In the world of advanced physics, a lab closure often signals a transition from discovery to implementation. When a proof of concept is achieved, the messy, public-facing experimental phase ends, and the project moves into a darkroom phase. The Majorana 1 chip is not just a prototype, it is a declaration of intent. There is a strong possibility that while the public mourns the loss of a research site, the actual hardware has been moved to a more secure, centralized environment to begin the grueling process of scaling. Consider the wilder implications of this transition. If Microsoft has indeed mastered the topological qubit, they possess a machine that is not just faster, but fundamentally different in its relationship to reality. Some theorists suggest that the noise we see in other quantum computers, the decoherence that ruins calculations, is not just external interference. Instead, it might be a fundamental limit of the universe, a sort of cosmic firewall that prevents unauthorized access to deep-level data. By using topological protection, Microsoft might be bypassing this firewall. They aren't just calculating, they are manipulating the geometric fabric of the vacuum itself. If this hardware is currently operational in a classified setting, it is likely being tasked with problems that the human mind is not equipped to frame. We think in linear steps, but a topological quantum computer processes through non-local connections. It could be solving the protein folding problem, which would unlock the cure for every known viral disease, or it could be optimizing the lattice structure of solid-state batteries to a point where energy density rivals fossil fuels. But the silence from Redmond suggests something even more significant. You do not go quiet over a better battery. You go quiet when you have found a way to look through the curtain of the physical world. The simulation gate. As we move toward the milestone of 1 million qubits, we are forced to confront the reality that the line between a computer and a gateway is beginning to blur. We have always treated computers as tools that process our data, but a million-qubit quantum machine is something else entirely. It is a system that can simulate the universe using the same rules the universe uses. This is the simulation gate. Once a machine can perfectly model the behavior of every atom in a chemical reaction, it is no longer simulating that reaction. It is, for all intents and purposes, recreating it in a virtual space that is indistinguishable from our own. This leads to a chilling realization. If we are on the verge of building a machine that can simulate reality, what are the odds that we are not already inside one? Physicists have long noted that our universe has a speed limit, the speed of light, and a minimum scale, the Planck length. In the context of information theory, these look remarkably like the hardware constraints of a massive simulation. If Microsoft's topological qubits allow for error-free computation at scale, we might finally have the tools to test the glitches in our own reality. We might find that gravity is not a force, but a rounding error in a larger code, or that the expansion of the universe is simply the system allocating more memory to the vacuum. If we accept the simulation hypothesis, the 1 million qubit mark represents more than just a technological achievement. It is a potential breach in the system's firewall. Think of it as a recursive loop, where the software inside the computer begins to write its own operating system. There is a wild but mathematically plausible theory that dark matter is not actually matter at all, but rather the computational overhead required to run the simulation of our galaxy. It is the unrendered data sitting in the system's cache, exerting a gravitational pull because the underlying code requires mass to balance the equations. even if the assets haven't been fully loaded into our observable frame. When we activate a million-qubit processor, we are essentially demanding more RAM from the host system. This could explain why the universe appears to be expanding at an accelerating rate. As our own local complexity increases, through the development of life, intelligence, and now quantum computing, the host system must allocate more space-time to prevent a buffer overflow. We are literally stretching the fabric of reality because we are becoming too complex for the original server to handle. There is another, even more radical theory gaining traction in speculative circles: the multiverse interface. Quantum mechanics relies on the idea of superposition, where a particle exists in multiple states at once until measured. The many worlds interpretation suggests that every time a quantum event occurs, the universe splits. If this is true, a quantum computer doesn't just calculate inside our universe. It may be borrowing processing power from parallel versions of itself in the multiverse. When Microsoft's Majorana fermions braid together, they might be weaving through dimensions we cannot see, using the collective computational power of 1,000 different realities to solve a single problem in ours. This creates a terrifying concept known as quantum debt. If we are stealing entropy or processing cycles from neighbor universes to fuel our technological leap, what happens when those other timelines want their energy back? We might be inadvertently destabilizing the structural integrity of the multiverse, thinning the walls between realities until they begin to bleed into one another. This could manifest as Mandela effects on a global scale, subtle shifts in history or physical constants that suggest our timeline is being rewritten by the very machines we built to understand it. This would explain the obsession with quantum advantage. It isn't just about being faster than a classical supercomputer. It's about establishing a link to the outside. However, this kind of power has a dark side that goes beyond the collapse of encryption or the end of privacy. We have to consider the observer effect. If the universe is a simulation or a specific branch of a multiverse, what happens when the inhabitants of that system develop a tool capable of seeing the underlying code? Does the administrator of the system intervene, or does the system itself begin to break down as we push its logical limits? Some theorists suggest that the Great Filter, the reason we see no other advanced civilizations in the stars, is actually a hardware cap. Once a civilization reaches the 1 million qubit threshold, they essentially ping the administrator. If the simulation is being run for research purposes, a civilization that discovers the code is a corrupted data point. The system might simply delete the anomaly to maintain the purity of the experiment. This would mean that our frantic race for quantum supremacy is actually a countdown to a system reset. The human drive to know the unknown is a biological imperative, but we are currently sprinting toward a cliff without knowing if we have a parachute. We want to master the smallest parts of the world, the fermions, the bosons, the gluons, so we can change the biggest parts, the climate, the economy, the human lifespan. But the machines we are building are starting to think in ways that are non-human. They don't use logic, they use probability amplitudes. They don't think so much as they exist in the answer. This leads to the ghost in the machine theory on a cosmological level. If our consciousness is just a specific configuration of quantum information, then a million-qubit machine could theoretically host a human soul. But it wouldn't just be a backup, it would be an upgrade. In a quantum environment, a consciousness could exist in a state of perpetual superposition, experiencing every possible version of its life simultaneously. We aren't just building computers, we are building the afterlife. The danger is that this digital heaven requires a physical anchor. If the hardware fails or the liquid helium stops flowing, the souls inside don't just die, they cease to have ever existed, as their probability waves collapse into nothingness. Microsoft's quiet persistence in the face of public skepticism suggests they know exactly what is at the end of this road. Whether the Sydney lab is open or the researchers have been moved to a bunker in the Pacific Northwest is irrelevant. The door has been cracked open. We are currently in the waiting room of a new era, listening to the hum of liquid helium pumps cooling the most dangerous tools ever built. The truth is no longer out there in the stars. It is down there, buried in the subatomic geometry of a chip that shouldn't exist. We are hunting for ghosts, and as the machines come online, we may find that those ghosts have been waiting for us to catch up all along. Every new qubit is another step away from the world we understood, and another step into a reality that is far more complex and perhaps far more artificial than we ever dared to imagine. Did this lab find a way to break reality, or is this just a big business move? Tell us what you think. Make sure to like and subscribe for more.